Okay, let's get started. In this chapter, we are looking at four main ideas: weathering, rates of weathering, how soil forms from bedrock, and soil conservation. Last week, we looked at weathering and how rocks break down into smaller pieces over time. This week, we will look at how bedrock becomes soil over time. Okay, just to get one thing straight, it takes a long time for rock to turn into soil. The soil that we have for growing food. If we waste that, nature won't be making any new soil for thousands of years. So if you like to eat food, this is important. Bedrock is not a bed made out of rock, but actually it is the solid rock layer that lies beneath the topsoil surface. Dig deep enough and you will find bedrock. The skyscrapers in New York City are actually anchored into the solid bedrock that lies many meters below the surface. But before we go any farther, here are a few terms that we should look at: soil, parent rock, bedrock, soil structure, soil texture, humus, soil conservation, and erosion. So, soil is the dirt, but there are many kinds of dirt that we will look at. Parent rock is the solid rock that used to be rock and now is soil. It gave birth to the soil. The type of rock that produces the soil determines the texture of the soil. Soil structure. What the soil is made of. Different soils have different parts. Soil texture is the quality of the soil based on how much of each part the soil has. Humus is the term for all of the dead organic material in the soil. Soil conservation is a method of using soils more efficiently. That means less waste. And erosion is when small pieces of rock are moved from one place to another. Now, once we see that the old solid rock is broken down over time to become soil, we can look at the properties of that soil. Depending on the structure of the parent rock, soil will contain different ratios of sand, silt, and clay. Sand has the largest particles of rock, anywhere from 0.05 millimeters to 2 millimeters per piece. Next is the silt at between 0.002 millimeters and 0.05 millimeters. That's small. And finally, clay is the smallest, at anything less than 0.002 millimeters. Remember, that's the size of each individual piece of soil. You can get a handful of soil yourself and guess what kind of particles it has. Now, all soil has some humus in it as well, the dead stuff. The more humus, the more fertile. But it is also true that silt is the best kind of soil for fertility. Too much clay, and the water can't infiltrate. Too much sand, and the water infiltrates too fast. Climate can also affect the soil. Climates with a lot of rain break down the soil fast and tend to have more clay, while deserts and the Arctic, which get little rain, tend to have more sand. Temperate climates are more balanced and thus have more silt, which is why temperate climates have a lot of fertile soil. What kind of soil do you think is under your feet right now? Now finally, we have to work to conserve soils because the particles of the soil are constantly being carried away by wind and water. This is called erosion. You can find many useful techniques for conserving soils in your book. Remember, most of our food comes from the soil. So, come to class ready to discuss and answer questions from section 3 and 4 of chapter 2, and have a great day.